you enjoyed the video. Now we're beginning our presentation. I am Zheng Jie, the team manager. This is Crystal, my resource manager. This is Jolie, my manufacturing engineer. And this is Xiangzhen, my design engineer. Let us move on to the agenda. I'll be first giving a general overview and an introduction to F1 in schools, followed by the summary of this year's World Championships. Crystal will then be talking about our marketing and sponsorship and introducing our sponsors. Because all of this would not have been possible without our sponsors. Jolene will then be talking about the 6 processes of designing a car in F1 in schools, from designing the car body with a CAD software, to manufacturing it with a CNC milling machine, to actually racing it with a CO2 canister, as you saw in the video just now. And lastly, Xiangzhen will be focusing on our use of ANSYS. F1 in schools, the only multidisciplinary challenge in the world to actually promote Formula 1 in use and to encourage future careers in science, engineering and technology. So what do we do in this challenge? What do we do in F1 in schools? Participants form a team of 3 to 6, participants form a team with 3 to 6 members. We have to plan our project timeline, for example, our portfolio, our marketing and strategy schemes. Each of us has our individual roles in the team to do our work with our strengths and weaknesses. At the same time, we also look for sponsors, and this will be talked to you more about by Crystal later, and also the 6 processes of designing a car. An interesting thing about F1 in schools, in 7 years, it has affected 9 million students' lives in over 30 countries. Henderson Secondary School has been doing quite well in F1 in schools since 2005. In 2009, we were crowned the overall champions for the nationals in Singapore with the fastest car, the best marketing and sponsorship, and also Xiangzhen even won the best reaction time award. As you saw in the video just now when you were firing the cars, they had to press a button, a trigger. He had the fastest reaction time that year. And for 2010's World Finals, because we have won 2009's Nationals, we were given a right to represent Singapore this year. I'm proud to announce that we have gotten the Best Team Identity Award. We have the 2nd fastest car with the help of ANSYS, and Jolie has the fastest female reaction time. We were also the 10th position out of 25 teams. It may not seem like much, but it is very close because this is the first year Singapore has actually gotten so far in the World Championship. Out of 300 points, we were only 30 points away from being world champions. It shows you how intense the competition is. The picture on the left is actually a gift exchange between countries. Every single team brings souvenirs from their own countries to trade with others. Later on that day after the gift exchange, you saw in the video, teams had to set up their booth displays, and it's a part of the judging. This picture shows our booth. There were also a lot of media interviews from our team to actually be featured on news. There were photo takings with Mr. Hawazi, Senior Parliament Secretary, Ministry of Manpower and Health. Over the competition, we also formed collaborations with many other countries, as you can see, Canada from the picture. Not only that, over the 25 teams, I think there were 16 countries. Each of us made very strong bonds during the competition. The next picture shows my design engineer actually introducing to the Senior Parliament Secretary about our F1 in schools and also showing the booth display. All of this would have not been possible without our sponsors, and so now I shall pass the time to Crystal to talk to you more about this.
Thank you, Zheng. As a resource manager, one of my jobs is to coordinate with members on the materials needed for the project. So when Xiangzhen discussed with me about the need for a good quality virtual wind tunnel software, I went out to search for the best DWT software that was able to meet our team's needs. And so after some research, we found ANSYS, CFD, and also found CAD-IT as a local distributor of ANSYS CFD. CAD-IT generously sponsored us the software and even attached an application engineer, Dr. Ma, to train our design engineer Xiangzhen on the software. And on behalf of the team, I would like to thank Dr. Ma for his patience during the training, and also Mr. Andy Tan for agreeing to sponsor us the software. KIT also has been listed as one of our platinum sponsors. And next I'll be going through about how our platinum sponsors have helped us through this project. I'll be focusing first on our main team sponsor, Schaeffler Group. Schaeffler Group offered us a Back 9 super precision ball bearings, and with these bearings we were able to achieve the time of the second fastest car, and also a monetary support of $7,000. And so with this high value of sponsorship, they were listed as our main team sponsor, and that was how our team name Schaeffler Hypersonic came about. And next, we also have some of our platinum sponsors like Ngee Ann Polytechnic, who has helped us machine the car out of balsa wood, rapid prototyping of aerofoils, and also implementation of AR module. Mickey Marketing sponsored us for OMP suits, which we are wearing now, to present ourselves in a more professional manner. And also lastly, Metayo sponsored us one license of Metayo Unify to present our car in augmented reality. Some of our valued sponsors, like example Dante Technologies, who has also helped us in the implementation of AR module. Freeform Solutions manufactured our wheels, and also Chevron sponsored us 40 thank you cards to show our appreciation to the sponsors. Now I'll pass my time to Jolene to tell you about the 6 processes of F1 in school. Thank you, Crystal. I'll be presenting on the 6 processes needed to create a car, and they are from research to race. From research, there are 3 aspects that we need to research on. They are the technical aspect, the innovation aspect, and the marketing and sponsorship aspect. For the technical aspect, we need to research on the previous car designs that hit the world record. And also, for the innovation, we research on innovation that are needed to help our car, that can benefit our car. And some of them are the static roll caps and the ball bearings. For the marketing and sponsorship aspect, we research on the companies with the necessary expertise that are needed to help for our project, which Crystal has mentioned earlier on. After all this, we can proceed on to our design. And Samson, our design engineer, will be able to design our car. Then he can further improve our car and create some innovations on the screens. They are the prototype rear aerofoils, which help in our car, because we don't need to manufacture 5 similar cars with 5 different rear aerofoils. So we can manufacture one car with 5 different rear aerofoils. This saves a lot of time for us. Then Samson can proceed on to the analyze of our car by using the CFD, which is the ANSYS CFD software, which Samson will be explaining later on. After knowing which designs which are better, we can manufacture our car. So as a manufacturing engineer, I will manufacture the car using a CNC machine, and the car will be given a good finish. And it will be followed by the testing of car, like using the wind tunnel and the accelerometer to test for it. So the wind tunnel will test it to find the drag coefficient of the car, and the accelerometer will know the acceleration of the car, and this we can further improve on our car. After that, we can finally race the car. Yeah, for now, I'll pass my time to Samson to tell you more about the analyzing of the car using the CFD software.
Thank you. Next, why will we choose for ANSYS? As you know, we use a CFD for our testing of car, right? So why will we choose ANSYS? Before that, F1 in school offered their own CFD software, right? But the result obtained is rather inaccurate, and it's only accurate for the wind tunnel test, as what Jolene has mentioned earlier on, and also it simulates as one geometry. Okay, but as for ANSYS, I'm able to simulate the car with turning wheels and along with the canister burst. At the same time, I'm also able to obtain results for different parts of the car individually. Okay, this is important because I need to choose my rear aerofoil carefully. Okay, at the same time with turning wheels, the drag coefficient will be different from what I can get from the F1 in school without DT. Okay, next, as all of you know in the project, a timeline is very important. Alright, so before that, without ANSYS, this is the timeline. For one car design process, I use about 1 week for the car design or researching, 2 weeks for my manufacturing engineer to manufacture the car, including sanding and spray painting of our car, and lastly, for the last week, we will use it for the testing on the racetrack. So basically, this one whole design will take about 1 month time. But with ANSYS, I can do my car design and my CFD testing in just 1 week. Okay, for this 1 week, I can do a simulation of 3 different designs, getting the best result before I move on to manufacturing. So if I were to do 3 car design, without ANSYS, it will take us about 3 months time for 3 car design. But with ANSYS, I will take only about 1 month. Okay, for simulation, I am able to get 3 different results, getting the best combination, manufacture it, and that's only 1 month's time. Which means I will save about 2 months time, and can use these 2 months for more other innovations thinking or researching on sponsors. In conclusion, ANSYS CFD has reduced a lot of time needed for the whole car design processes, and also it reduced the resources used, save us a lot of time and the fossil use. So with that, looking at these two pictures, people always tell me that the one on the left look more aerodynamic because it look more streamlined as compared to the one which I conducted the ANSYS test, right? But no, without ANSYS, I only can obtain the timing, which is 1.124 seconds, and I do not know anything about the pressure contours or the drag coefficient. But with ANSYS, after doing all this simulation, okay, I get the drag coefficient, which is important for our portfolio, the pressure contours, velocity streamline, and also, even though it doesn't look as aerodynamic as what the picture on the left shows, but it have a better timing. With all this testing, I'm very proud to say that we clock in the second fastest time. Okay, thanks for ANSYS. So with that, I'm able to choose my car bodies. I have 3 different designs over here. Okay, so running a simulations, I get different airflow. As you can see for design 1 and 2, there's disrupted airflow, which is not what I wanted. As for design 3, I have an even better airflow, a smoother one. For that also, like I mentioned before, I'm able to get different results for different car parts. So I use this to choose my rear aerofoils. Taking 2 examples, rear aerofoil 1 and aerofoil 2. And I have the same car body, as you can see the pressure contours is almost similar, but the pressure acting on the rear aerofoils is different. So from here I'm able to know which is a better one, give me a smoother airflow, and also at the same time use this with this result to choose the aerofoil that best fit our combination. For that, that's the end of our presentation. Thanks for your kind attention.